Okay, now we're going to talk about solving using substitution. So we've practiced this before in LT4.0, so we're just going to have some more practice. So notice we have y equals this stuff and y equals this stuff. So it should make sense that if y is equal to this and if y is equal to this, then the two pink things should be equal to each other since they're both equal to y, right? So now I'm just going to write negative 2x plus 14 equals 3x minus 11. And let's see, so I could add 2x on both sides. Then that goes away. And then I'm left with 14 equals 5x minus 11. And now let's add 11 on both sides, plus 11. And that's going to make this go away. And then I've got 11 and 14 is 25 equals 5x. And then the last step here is I'm going to divide both sides by 5. And I get 25 divided by 5 is 5. So now I get x equals 5. Okay. So now I could plug it into one of these equations. It doesn't matter which one. Let's say y equals negative 2x plus 14. Okay. So I have y equals negative 2. So I'm going to replace this x with 5. Okay, so now I've got negative 2 times 5 is negative 10 plus 14, and then that's going to give me y equals 4. Okay, and so my solution is 5 comma 4. That's my answer. Okay, let's do our next one. So similar to before, we know y is equal to this stuff, and then we have this other equation that's in standard form. So basically what I'm going to be doing here is I'm just going to be replacing y of this equation with the pink stuff. So now I simply rewrite the second equation, 5x minus, I'm going to put a parentheses here, equals negative 21. Okay, and in the parentheses, I'm going to put all that pink stuff. What was the pink stuff? Because that's equal to y. We're going to write in negative 4x minus 15. Okay, and so then we multiply this negative times that. And this is where people struggled a little bit in class today. So we have 5x. So negative 1, or negative times negative 4. So this is going to give me plus 4x. And the negative times the negative 15, we're going to end up with plus 15 equals negative 21. Okay? So now I can combine the like terms. The 5x and the 4x is going to give me 9x plus 15 equals negative 21. Okay, because these two add up to give me 9x. And then now I'm going to have to subtract we're going to subtract 15 on both sides of the equal sign, and that makes that go away, and then I end up with 9x equals negative 21, and negative 15 is negative 36. And now my final step is I'm going to divide everything by 9, and then I get x equal negative 36 divided by 9 is negative 4. Okay, and now I need to substitute negative 4 back into this original equation, and so I get y equals negative 4 minus 15. So we're going to substitute negative 4 in place of x. Okay, negative 4 times negative 4 is positive 16. And 16 minus 15, it gives me 1. So my solution is negative 4 comma 1. Okay, let's do number 3. Okay, so just like before, we know y is equal to this stuff, so I'm going to replace y of that first equation with the pink stuff. So I'm going to rewrite the first equation, 6x plus 7 and times the pink stuff equals 13. Okay, what is the pink stuff, you may ask? Negative 3x plus 19. Okay, so now we do distributive property, and I get 6x minus 21x, and then 7 times 19 is 133. Okay, so now I can combine negative 6x and negative 21x. That gets me negative 15x plus 133 equals 13. Okay, so I need to subtract 133 on both sides, and then I end up with negative 15x equals, and 13 minus 133 is going to give me negative 120. Okay, and then my final step here to get x is I'm going to divide both sides by negative 15. And then I end up with x equals 8. Remember, negative divided by negative gives me positive. Okay, and now we're going to solve for y. So we know y is equal to negative 3. Let's just put it on here. Negative 3x plus 19, right? That's the equation right here. Okay, so I'm going to replace x here with 8, and then I get y equals negative 3 times 8 plus 19. So we get y equals negative 24 plus 19, y equals negative 5. So my solution is 8 comma negative 5. Okay. And let's do number 6. Okay, so now we're used to having y equals something, and nothing looks like that right here. So if we're going to use substitution, what we need to do is we need to rearrange this equation so that it's y equals. And fortunately, all we have to do is subtract 6x on both sides, minus 6x, because then, and then we will end up with y equals negative 6x minus 17. Okay, so this is some people in class today had a little difficulty with this. So we subtracted 6x on both sides of the equal sign, and then we're just left with y equals negative 6x minus 17. Okay, and then the pink stuff is this over here. Okay, I need a new pink marker. Okay, so now I'm going to rewrite the second equation. 2x minus 5 times parentheses equals negative 11. And what do we write in the parentheses? We're going to write negative 6x minus 17. Okay, distributive property with the negative 5 there and the negative 5 times that. So then I end up with 2x, and negative 5 times negative 6x is going to give me plus 30x, and negative 5 times negative 17 is going to give me plus 85 equals negative 11. All right? Okay, and then 2x and 30x together, that's going to give me 32x plus 85 equals negative 11. Okay, now to solve for x, we need to subtract 85 on both sides. Okay, and we get 32x equals negative 11, and negative 85 is negative 96. And then final step to find x is we have to divide both sides by 32. And so negative 96 divided by 32, and we end up with x equals negative 3. Okay, and now I'm going to use this orange equation to find y. So using the orange equation, we know y equals negative 6x minus 17, right? So I'm going to replace the x with negative 3. So then I get y equals negative 6 times negative 3 minus 17. And so I get y equals positive 18 minus 17, so y equals 1. Okay, and so my solution is negative 3 comma 1. Okay, so let's do the next page. Okay, so solve by graphing, solve algebraically. Okay, to solve by graphing, I need to rearrange this first problem here. So I have x plus 2y equals 4. Okay, so to make it look in y-intercept form, I could subtract x on both sides of the equal sign, and then I get 2y equals negative x plus 4, and then I divide both sides of the equal sign by 2, and then I get y equals negative 1/2 x plus 2. Okay, that's one of my equations. And the other equation, I've got 2x minus y equals negative 8. So I'm going to subtract 2x on both sides of the equal sign. And then I get negative y equals negative 2x minus 8. And to solve for y, we have to divide both sides by negative 1 in order to make this positive y. And then I end up with positive y equals positive 2x and then plus 8. Okay, so let's graph these two equations. This first one, I'll graph it in orange. My y-intercept is at 2, so I'm going to put a dot at 2, and my slope is negative 1/2. So I go down 1, over 2, down 1, over 2, down 1, okay? And I can graph this. Okay. And the other one, I'll do it in blue. So my y-intercept is at 8, and my slope is positive 2. So up 2 over 1, I can go this way. And graph. Okay, and my solution, it's not an integer, it's somewhere around here. Okay, so if we want a more accurate answer, we're going to have to do this algebraically. So using substitution is one way. So what I recommend, so let's use this first equation. One thing I do is I put like a 1 with a circle and a 2 with a circle. This helps me identify which equation I'm working with. So I'm just going to write the first equation, which is x plus 2y equals 4. Now, instead of writing y, I'm going to write 2x plus 8, okay, because this is for my second equation. So I'm going to replace y here with the 2x plus 8 from the second equation. Okay, let's go right there. Okay, now I can do distributive property here, and I end up with x plus 4x, and then 2 times 8, so plus 16 equals 4. All right, let's combine some like terms. We have x and 4x, so that's going to give me 5x plus 16 equals 4. And then I can subtract 16 on both sides. And then I'm going to end up with 5x equals negative 12. And then my final step is we divide both sides by 5. And then I end up with x equals negative 2.4. Okay. Now it looks like we're out. The x value is negative between 2 and 3, looks like. Okay, now let's find our y value. Let's take one of these equations. How about y equals 2x plus 8? Doesn't matter which one I use. Okay, and then I'm going to replace x. I'm going to replace this x here with negative 2.4. Okay. So 2 times negative 2.4 is equal to negative 4.8. And then negative 4.8 and 8 is going to give me 3.2. And so my solution is negative 2.4 comma 3.2. Okay, I guess I'm supposed to write that down here. Okay, and if you look at the graph, that kind of looks like negative 2.4 and up 3.2. Kind of looks like that. So which one is more accurate? The algebraic is definitely this more accurate. Which one's better to visualize? The graph is a nice way to visualize what's going on. Okay, so they want you to show that this satisfies the equation. So let's look at it two different ways. So from equation 1, it's equation 1 was x plus 2y equals 4. So I'm going to substitute x with negative 2.4 plus 2 times 3.2 equals 4. And then that gives me negative 2.4 plus 6.4 equals 4. And then I get 4 equals 4, which correct. And let's try the next one. We've got the other equation is 2x minus y equals -8. And so I'm going to replace x with -2.4 and y with 3.2, so I end up with 2 times -2.4 minus 3.2, and that should be equal to -8. And let's see, so two times -2.4 is -4.8 and -3.2. And then voila, if you add those two values together, you would end up with -8 equals -8. Ta-da. Hit pause, go back if you need to see this some more.